So, we'll now talk about the concept of sign numbers in computers. So, the concept of sign numbers in computers, we know that numbers could be used either positive or negative, right? So, for example, we could have a 5 degrees below 0, meaning negative 5 degrees, or 20 degrees above 0, or positive 20. So, computers must be able to accommodate such numbers. In order for us to accommodate that in AVR na microcontroller, we have this for an 8-bit na microcontroller like AVR. We could have D0 to D6 as defining the magnitude of the number, and the D7 or the 8-bit is the sign. It would indicate if it is a positive or negative. So this D7 is 0 for positive and 1 for a negative. So if we have 1 here, meaning our number is a negative. And if it is 0, then it is positive. So in sign byte operands, the D7, as I've said, is the sign, and D0 to D6 are set aside for the magnitude of the number. So if D7 is equal to 0, the operand is positive and D7 is negative. So D7 represents the status of our N flag, katong status register nato. So if our N flag is equal to 1, meaning it is negative. And if our N flag is 0, then it is positive. So our positive numbers ranges from 0 to 127. Beyond that, na possibility mag-overflow. Overflow na siya kay we just have 8 bits. So 2 to the power of 8 is 128 since mag-start of 0. So 0 up to 127 lang ang atong ma-accommodate. That is for an 8-bit. But if we target nga larger than 127, we could have or we could use a 16-bit operand nga atong gamiton. So, in order for us to have a negative number, again, D7 is 1. However, the magnitude is represented in its 2's complement. So, always jud na ang katong pinaka last na digit is 1 kung negative, then ang katong the rest ang 0 to 6 nga digit is a 2's complement sa katong magnitude. So for example, so in order to convert negative numbers representation or the 2's complement, first, we write the magnitude of the number in 8-bit binary, walay sign. Then after that, invert each number and then add 1 to it. So here we have an example. How can we show in AVR to represent negative 5? So the solution is first, write the 8-bit binary of the magnitude 5. So we have the first nibble 0, 0, 0, 0, 0, 1, 0, 1. So 5. The first nibble is 0. Tanan. And then, i-invert nato ni siya nga binary. So 1, 1, 1, 1, 1, 0, 1, 0. Then, mag-add ta og 1. So, we have 1, 1, 1, 1, 0, 1, 1. So, that would be the representation of our negative 5. So, from the magnitude nato nga 0, 1, 0, 1 as 5, then invert, then plus 1. And then, so negative 5, if we write it in hexadecimal, it could be represented as FBH. So the sign number representation in 2's complement for negative 5. Again, D7 is equal to the N flag of the status register, in which it is equal to 1, indicating that the number is negative. So for negative number, we have here, how would we represent negative 128? So for a negative 128, we have 1 0 0 0 0 0 0. That is the magnitude of 128 in binary. And inverting it is 0 1 1 1 1 1 1 1 1. And adding it to 1, balik gyapon siya sa 1 0 0 0 0 0 0 0. So as you can see, negative 128 is equal to 80H, the sign number representation in 2's complement for negative 128. And D7 is equal to N is equal to 1, indicating that this number is negative. So notice that 128 binary is kini siya nga value in unsigned representation is same as sign negative 128 gyapon. Pareho ra sila. But if ever nga later on ma-discuss nato tong V na flag o S na flag to identify jud kung unsa siya nga sign if atong tan-awon. But in here, negative 128 o 128, same ra sila og representation for the binary. So for our negative numbers, as you can see, negative 1 up to negative 128, all are having 1 sa diri na value. And for the positive from 0 to 127, 0 siya. So this is limited for an 8-bit because 0 up to 127. Matong na possibility nga magpareho ang 100 positive 128 o negative 128 kay ni go beyond naman ta sa binary.